Welcome to this video on the topic of linear functions. In this video, we're going to have a look at how we can go about graphing a linear relationship. Or in more technical terms, we're looking at how we can transform the algebraic representation of a linear function into that of its graphical representation. Now we can go about doing this in 3 easy steps, provided that the algebraic representation of our linear function is in general form. That being, all of our variable terms are on the left hand side of the equal sign and all of our constant terms are on the right. Moreover, we have our x term on the far left and then we have the y term to the right of the x term. The a coefficient in this equation, by convention we try to keep it positive. It doesn't always have to be positive, but by convention we like doing that. Now, when we're in this form here, we're able to graph this or turn this into its graphical representation in 3 easy steps. The way in which we do it is, firstly we find the x and y intercepts and then we simply plot them on a Cartesian plane and then draw a line that cuts through both of those points. So what you can see is the steps you do is you simply find the x-intercept, the y-intercept, and then you plot them. So let's go down and do a few examples. Example A, we have x plus 4y equals -4. So we can see that this is a linear relationship. Now we're going to go about plotting it. So the way in which we do that is, firstly we need to find the x-intercept. So I'm going to go down and I'm going to write finding x-intercept. Going up, we have x plus 4y equals -4. So I'll write that out as well. Alright, now for the y or for the x-intercept, we know that the x-intercept is going to occur when we cut the x-axis seen here. So when this occurs, we're always going to see something of the likes of unknown, and then we're going to get a y value of 0. So the way in which we find the x-intercept is we simply change y to 0. Now I can explicitly state or communicate what I'm doing by writing it out like such. So I'll go let y equal 0. And that will be where my x-intercept occurs. Now subbing in the value, x is unknown, but my value for y is now 0. Now all I need to do is solve for x. So the 4 times 0 is simply 0, so x is going to be -4. And therefore my x-intercept is at -4 and 0. So nice and simple. Plotting this on the Cartesian plane, we're going to go to -4 and 0. And that's our first point on our Cartesian plane here. Alright, so now that we've got our x-intercept, the next step is to find the y-intercept. So I'm going to write finding y-intercept to communicate to the audience what I am doing. I will write out the original relationship. The y-intercept is going to occur when x equals 0. So in other words, when we're cutting our Cartesian plane at a location like this, at this point, the x value is always going to be 0 and the y is unknown at this point in time. So to synthesize a value where we can find our y-intercept, we simply set x to 0 and observe the behavior. Subbing in 0, we're presented with 4y equals -4. I simply divide both sides of the equation by 4 and I get a result of -1. So therefore my y-intercept is going to be at a value of 0 and -1, like so. Plotting this on my Cartesian plane, I'm going to go to 0 and -1, and that's going to be, and then my next step is I actually need to plot this. So I need to draw a line that's going to go through both of these points. So I'll get my ruler out and I'll draw a straight line, and then I'm going to make it go through these points. Finishing up, we're going to draw arrowheads on our new line we've drawn, and then I'm going to make sure that my Cartesian plane is labeled as well. So my x-axis, this is the positive direction by convention, and then my y-axis. And what we've been able to do is we've turned our algebraic representation seen over here into a graphical representation over here. Now in the chance that you have more than one line on a Cartesian plane, to be explicit about the information you're communicating or what line represents what relationship, you can write out the relationship. Then we are allowed to place it on top of our line. So the reason this is a really good practice to do is it allows you to easily identify which line belongs to which relationship, like so. You don't have to do it, but it's always a good idea, especially if you have more than one line on the single Cartesian plane. So this is example 1. First thing we do is we find the X and the Y intercepts, then we plot them, and then we draw a line through them. Easy does it. Alright, next one for B, we have 5x minus y equals 5. First thing I'm going to do is I'm going to get my ruler and I'm going to draw up a Cartesian plane ready to receive the information. Not too bad. Okay, I'm going to put my arrows and I'm going to mark out the convention, so y plus, x positive. Okay, next step. Let us find our X intercept. Our relationship is 5x minus y equals 5. And then the X intercept is going to occur when the value of y is equal to 0. So we're going to say let y equal 0. It's always a good practice to write this little sentence out here because it communicates to the person reading your math what you're actually doing here. So whenever we see y, we substitute in the value of 0. As a consequence, the resultant equation is going to be 5x minus, or 5x equals 5. And then we're going to get 5x equals 5. Dividing both sides by the coefficient in front of x, we're going to find that our x is therefore equal to 1. Therefore, our x-intercept is located at 1 and 0. Moving forward, I'm going to put this on my Cartesian plane. So I'll plot 1, 0, and that's located here. Easy does it. Okay, we need one more point to be able to graph this linear relationship here. So 5x minus y equals 5. Now we're going to look for our y-intercept. To find our y-intercept, we're going to set the value of x to 0. Consequently, the y is unknown, the value of x is now 0, and everything else is still in its place. 5 times 0 is 0, so we're going to get minus y equals 5. And then to remove the negative, we can either divide by -1 or we can times by -1. My favorite method is multiplying by -1. Therefore, the location of the y-intercept is at y equals -5. 0, -5, let's go up and we'll plot it on our Cartesian plane. So we go 0, 1, 2, 3, 4, 5, -5. Now next step is we need to actually draw a line between these 2 points. So I'm going to get a ruler and I'm going to draw a line that goes through these 2 points. Remember, the line itself doesn't terminate on the point, rather the line goes straight through the point. Reason being is that the line is not a line segment, as in it's not a portion of a line, but rather it's continuous, and we denote that by drawing arrows on it like so. Alright, too easy. Now once again, to finish this off, what we can do is we can get our pens and then we can write out this relationship on the line. And thus we have successfully graphed our linear relationship seen over here. This is our algebraic representation, this is our graphical representation. Alright, final one. We have C. Let's get C and we'll move it somewhere sensible, like here. What I'm going to do is, I've got my C and now I'm going to draw up my Cartesian plane using a ruler so it's nice and neat. Alright, jumping into it, we're going to first find our x-intercept. The relationship is x minus 0.6y equals 3. Now the x-intercept is going to occur when y equals 0, so I'm going to say let y equals 0. Adjust my equation accordingly. And then I'm going to solve for x. So the x-intercept is going to occur at 3 0. Marking this on the Cartesian plane, 3, 0. Now we need to find the y-intercept. We're going to say let x equal 0. Every time we see x, we now replace it with 0. And we need to solve for y. We're going to get negative 0.6 y equals 3. Then we need to divide by negative 0.6. Thus what we're going to find is that our value of y is going to equal negative 5. And therefore our y-intercept is going to be at location 0, negative 5. Plotting this, 1, 2, 3, 4, 5. We're going to get 0, negative, getting a ruler and drawing a straight line. Ensure the line passes through both of these points. Draw my arrows. Then I'm going to write the relationship that describes the line. And thus we conclude how we can go about graphing our linear relationships.